Okay, so since you have an idea about rectangular motion, the next part sa curvilinear motion is what we call projectile motion. Are you familiar with projectile motion? Okay, so actually the best definition is an object that is thrown into the air or projected into the air. So that is actually simply how you define a projectile motion. Di ba napansin ninyo kung if you throw a object or any object into the air is ang ma-form niya na motion is a curved path. And that curved path is what we call a projectile motion. Ang projectile motion is the same with free-falling body. That's why the equations na ako ang discuss later on are similar to free-falling bodies. It's because the fact that when you throw an object into the air, the only force that acts on the body is the gravity. So that's why the acceleration nato ana during the free-falling body and also the projectile motion is always constant. Ang acceleration niya is a constant, which is what we call the gravity. So speaking of the projectile motion, the free flight motion of a particle is often studied in terms of its rectangular components. So since you knew already the introduction or some basics for rectangular components, so this is an example of an image when we analyze projectile motion. So it has a, what you call this, initial position. So this is before the object is thrown into the air. And then, kani is mo nang iyahang final position with its final velocity. And to illustrate the kinematic analysis, so when we talk about kinematic, we talk about the geometric aspects, its velocity, the position, velocity, and acceleration. We consider a projectile launched at a point that is at the initial point with an initial velocity of VO and having a components of VOX and VOY. And when air resistance is neglected, so nag-mention na air resistance is neglected because when we analyze projectile motion, we always neglect air resistance. Okay? Eh kung naay air resistance magod, lahi na siya na topic. I don't know if it is in aerodynamics ata. Not sure if what topic ma-discuss, pero it's part also sa dynamics, pero on the higher level siya. Pero in projectile motion manggod, we always neglect air resistance. And the only force acting on the projectile is its weight, and it causes the projectile to have a constant downward acceleration of approximately equal to the gravity, which is equal to 9.81 meter per second squared. That is, if ever SI ang problem, or 32.2 feet per second square if ever English ang unit na ginagamit sa problem. So that's why kung sa rectilinear na itong gidiscuss before, we actually discuss a topic kung asa ang acceleration is constant, di ba? So that is what we call free-falling body. Itawag siya free-falling kay tungod ang path niya is a straight line. Pero kung if ever a path is a curved path and if the acceleration is a constant, the type of topic that we discuss here is what we call the projectile motion. So for the projectile motion, again, this is the gravity. So that is the constant acceleration that acts during the motion of the particle that is thrown into the air that forms into a curved path. And sa projectile motion, since we discuss about rectangular components, ma-divide nato na siya into two motions. That is in the horizontal and in the vertical. So sa horizontal motion, since the x component sa acceleration or ax is equal to 0, since diba, the acceleration along the y-axis or y direction is constant, so our ax is equal to 0, the application of the constant acceleration equations yields to the following. And I believe that you're familiar with these three equations. Mo na itong i-discuss sa rectilinear motion sa free-falling body. So the same gihapon ang gamiton nato sa projectile motion. So using this equation, and when we substitute the corresponding values based sa figure kanina, kung sa initial velocity and initial velocity, final velocity, and also its initial position and final position, we will derive with this three equations rather. So if you notice, is that the first and last equations indicate that the horizontal component of velocity always remains constant during the motion. So in describing the motion of a particle horizontally, ang equation na magamit nato ani is the second one, the second equation. So I will discuss that later on. Next is on the vertical motion. Since the positive y-axis is directed upward, so to designate the sign sa imong gravity, that is a negative g. So the same natong gibuhat kanina sa horizontal motion. We have actually the same equation na gigamit sa free-falling body. And if we substitute the initial position and velocity and the final position and velocity, so we come up with these three equations. We recall that the last equation, which is this one, kaning last equation nato, can be formulated on the basis of eliminating the time from the first two equations, and therefore only two of the above three equations are independent of one another. So most likely kung mag-describe tag motion vertically, what we actually i-memorize lang are the first two equations. Ma-derive lang nato ang third if we combine the two equations and eliminating the variable t. So for that, in summary, problems involving the motion of a projectile can have at most three unknowns, since only three independent equations can be written, that is one equation in the horizontal direction and two in the vertical direction. So once the x and y components of your velocity are obtained, the resultant velocity, which is always tangent to the path, can be determined by the vector sum. So just a summary, mao ni ang equations na gamiton to describe the horizontal direction and also for the vertical direction. So if you notice here, kaning sa vertical direction, dili siya naka-positive, itungod gi-substitute na directly ang sign sa imong gravity, which is a downward acceleration. When we consider downward acceleration, that is a negative sign. So mo na negative gt ang sa first, and ang sa second is negative 1/2 gt squared. Diba sa original equation, that is plus act, and the second is plus 1/2 act squared. So kana is diretso nag o giapil na gibali ang sign sa gravity. So just a procedure for analysis, when we solve a motion of a projectile, we The same lang gihapon sa rectangular components kanina, or sa previous nato na topic sa rectangular components. We start on establishing the coordinate system. So we establish the fixed XY coordinate axis, and we sketch the trajectory of the particle. And between any 2 points on the path, you specify the given problem data and identify the three unknowns. In all cases, the acceleration of gravity acts downwards and equal to the either 9.81 kung SI or 32.2 kung English. And the particle's initial and final velocities should be represented in terms of their X and Y components. And remember that positive and negative position, velocity, and acceleration components always act in accordance with their associated coordinate directions. Once you establish the coordinate system, kanang ma-establish nimo ang iyahang curve path in the coordinate system mismo, you can now apply the kinematic equations. So it depends upon the known data and what is to be determined. A choice should be made as to which three of the following four equations should be applied between the 2 points on the path to obtain the most direct solution to the problem. So just a recap, mao ni ang equations horizontal, especially that its velocity, the x component of its velocity is always constant. And for the vertical motion, we have actually three, but we can use only the first two equations since the third equation can be derived when we combine the first two equations, eliminating the variable t. So once makombine nato ning two equations and eliminating the t, the variable t, we can derive the third equation. So most likely, ang atong magamit ani is the kaniyang sa horizontal and ang sa vertical are the first two equations. And for example, if the particle's final velocity Vy is not needed, then the first and third of these equations will not be useful. So that is how you what do you call this? Analyze a projectile motion, or if you encounter a problem that is a projectile motion. Mao na kung projectile motion, mas dali siya kay tungod na formula daan. You just remember this equation for the horizontal and the vertical, and then you can determine unsay gipangita sa problem.